Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 2.3.1. Our M&Ms for this particular lesson are giving you a strategy that you can use, the generic rectangle to multiply mixed numbers together. This absolutely works. If you think of, it's kind of like distributive property. It's based on that idea where 2 and 1/2 is literally 2 plus 1/2, and 1 and 1/4 is literally 1 plus 1/4. When you're using distributive property, when you've got a situation like this, and you're going to learn a lot more about this in high school when you have to solve problems like x plus 2 times x minus 3, you're going to be using something like this quite a bit to solve that problem, or you're going to send in multiple dive bombers and torpedoes. But let's just stick with this for right now. So we understand that 2 and 1/2 is 2 plus 1/2, and 1 and 1/4 is 1 plus 1/4. So we're going to have to multiply the 2 times the 1, the 2 times the 1/4, the 1 times the 1/2, and the 1/4 times the 1/2. Now, what I'm not crazy about with this method is you end up getting a bunch of different fractions that have to be added together, which means you're going to have to find common denominators. And while this worked out nicely, since we know that 1/2 plus 1/2 is 1, so you end up with 3 and 1/8, sometimes it's a mess. So I'm not a huge fan of using this technique for multiplying mixed numbers together. I always like to change my mixed numbers to fractions and then just multiply straight across, and you never have to worry about common denominators when you're multiplying fractions together. So 2 and 1/2, if I could use my model again, 2 and 1/2, how many total halves are there? 1, 2, 3, 4, 5 halves. And 1 and 1/4, how many total fourths are there? 1, 2, 3, 4, 5 fourths. So 5 halves times 5 fourths is 25 eighths, which then you do the division. How many eighths can you fit into 25? Let me actually show the division algorithm here. It goes in 3 times with a remainder of 1. So this becomes 1/8, where you put the remainder on the top. Let me move that over a little bit so you can see it. And the original fraction denominator, what you're dividing by, goes in the denominator of your answer, what was left over. So 3 and 1/8, either way that you choose to solve it, both of them work. All right, problem number 115. What are we doing here? We're properly scaling a number line. So here, to get from 32 to 64, you are going 1, 2, 3, 4 steps to get there, and 64 minus 32 is 32. So if it takes you 4 steps to go 32 units, how much is each step? It must be 8 per step. So we're going to count by eighths, and you will see that all that fits in nice and neatly. Same thing applies here. You got 1, 2, 3, 4 steps to go 1. So 1 divided by 4 means we're counting by fourths or by quarters. In this case, you're going 2 steps to go 1. So 1 divided by 2 is 1/2, but I wrote it as decimal numbers, but you could have written it as 1/2, 1, and 1.5 instead of as the decimal. And then here we're going, remember, this is 0, right? That's the origin, 0, 0. So we're going to go 1, 2, 3 steps to go 9. So that means you must be counting by threes. And here you're going 1, 2, 3 steps to go 12. So each step must be 4, 4, 8, 12. And here you're going 1, 2, 3, 4, 5 steps to go 20. So you're counting by fours as well here. Now, something to consider when we are talking about number lines. You can count by any number sequence you want on the number line. You can count by 2s, by 1s, by 5s, by 8s, by fractions. It doesn't make any difference as long as each one of these units is equally spaced and the number in between them is equal. So you're counting by eighths, they're all equally spaced. That's a proper number line. When you're dealing with 2 number lines, like with the coordinate grids, the x-axis does not have to have the same counting sequence as the y-axis. You don't even have to be spaced the same way. You could have had multiple spacings here where they're much, much closer together than these were. So they're two completely different number lines. You're allowed to have them be different, but everything on the X line needs to be following the rules of the number line, and everything on the Y line has to be following the same rules as all number lines. All right, take a look at our diamond problems and the patterns. Remember, you multiply these two numbers on the side together and write the answer, the product on the top, and then you add those together, and then you write that sum on the bottom. So here's a question. What two numbers do you multiply together to give you 0? Well, you know one of them has to be a 0 because that's how 0 product property works. If two numbers multiplied together is equal to 0, then one of those numbers must be a 0, or possibly both of them. But in this case, we know it's not both because something plus 0 gives you 25. So that's where the two numbers must be 25 and 0. Here, you know that you're multiplying 6 times something to give you negative 30. So what would you multiply? Well, do the division. Negative 30 divided by 6 is negative 5. So that means this number has to be negative 5. So now you're going to add 6 and negative 5 together to give you 1. So that's the sum at the bottom. Here, it's a little bit easier to figure out because what do you add to 11 to give you 25? It must be 14. So 11 times 14 is 154. Problem D, without question, is the most complicated. Much, much more complicated than A was, because what two numbers do you multiply together to give you 234? There's a lot of different combinations that you could multiply together to give you 234 for an answer. So you kind of have to go through all the different combinations until you find the combination of factors of 234 that have a sum of 31, and it ends up being 13 and 18. If you understand these, but this one was really hard for you, that's not for whatever. I don't like this example. I think that's a little bit too early to expect you to find this easy. I mean, some of you probably figured it out, but it wasn't easy. That's all I'm saying. If anyone absolutely needs me to work that out for you, I will. I just don't want to. Okay, now, adding mixed numbers together. Do not use a calculator, okay? You need to know how to do this. Someday in the future, you can change these fractional numbers into decimal numbers and then add them together. But the problem is like a problem like this one right there, where 1/6 is a repeating decimal. So it's going to affect the accuracy of your answer if you convert them to decimals first. So let's just learn how to add these together using our knowledge of fractions. So 7 and 5/8 plus 2 and 9/16. Let's just separate those into two different parts. You know the 7 and 2 make 9. What do we get when we add 5/8 and 9/16? Well, 5/8 plus 9/16. It looks like our common denominator should be pretty easy to find there, right? Just make that a 16 and make that a 10. And now we're going to add 10 and 9 together to give us 19 over 16. But I do not want to see an answer that says 9 and 19/16. You're not allowed to write a mixed number with a whole number and an improper fraction. You can't do that. So we're going to have to change this. So 19 over 16 becomes 1 and 3/16. Now let's add that to the 7 plus 2, which is 9, and that's how you get 10 and 3/16 for your answer. Okay? So whenever you're adding, it's a lot easier with the adding than subtracting. You can actually break this up into 2 plus 6, right? And then the 7/8 plus 1/6. So this part we know is going to be 8. What is this going to be? You could use the coat of arms if you want to, or I see that they both have 24 in common, so that's what I'm going to use for my common denominator. And that was times 3, so we'll multiply that times 3, and that's a 21. This was times 4, so I'll multiply the 1 times 4 to give you 4 over 24. And now you've got 25 over 24, which is the same as 1 and 1/24. Add that to the 8, and you get 9 and 1/24. This problem, the most common wrong answer is 2 and 2/5. because people don't remember that when you're subtracting, you've got to line everything up, right? So 8 minus 6 2/5, you can't, there's a 0 fifths here, right? 8 0 fifths is just 8, but you can't take 2/5 away from nothing. This is where we need to borrow from our neighbor, change that to a 7, and we took away 1 from that, right? So I'm going to write that 1 as a fraction with the denominator of 5. So this becomes 7 5/5, which is 7 plus 1, which is 8. Now I can do the subtraction. 5/5 minus 2/5 is 3/5, and 7 minus 6 is 1, so that gives us our answer. Okay, now let me show you what this would look like if I were to draw a picture. We start off with 8 circles. 1, 2, 3, 4, 5, 6, 7, 8 perfectly drawn circles. I've got to take away 6 2/5. So I'm going to take one of these circles and I'm going to change it into fifths. So now we've got 7 5/5. And now let's take away 1, 2, 3, 4, 5, 6, and now let's take away 2/5. There's 1/5. There's 2/5 that have been taken away. What do we have left? 1 and 1, 2, 3 fifths. Sometimes drawing the picture it helps it make more sense of why we do what we do when we are subtracting mixed numbers. Carmen is drawing a card from a standard deck of playing cards. Find each probability. Okay, so blah, 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 blah. What's the probability she will draw a heart? Well, we have to remember the basics of how cards work. You've got 4 suits, right? You've got hearts, you've got diamonds, you've got clubs, and you've got spades, which kind of, so you got all those. That's not a very good looking spade. Let's do an upside down heart with a little, that's almost like a mushroom, looks like. Okay, so we want hearts, right? And there are 13 cards in each suit for a total of 52 cards in the deck. We're only going to focus on the hearts. So that means you've got 13 out of the 52 would be a heart to draw, which simplifies down to 1/4, since the hearts represent 1/4 of the deck, the diamonds represent 1/4, the clubs represent 1/4, and the spades represent 1/4 of the suit. What is the probability that she will not draw a club? Well, that's not a club, that's not a club, and that's not a club. So that means you've got a total of 39 cards in there that are not clubs, which is 3 out of the 4 suits are not clubs, and that's why it's a probability of 3/4 of not drawing a club. All right, I am going to show you something for the very first time that might make your jobs a lot easier. If you've got access to your Chrome account, your Chromebook, or whatever computer you're using, then you should have access to your drive, which allows you to create a spreadsheet. So you go to new, stop it, cancel. You go to new, why you do that for me? Don't do that. Well, I guess I can't show it to you, but you click new and it's supposed to give you an option for going to Google Docs, Google Slides, Google Forms, Google Spreadsheets. Choose a spreadsheet and you've got all these cells in here, okay? So what we're gonna do is this. I'm going to copy down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all 12 of these numbers into the spreadsheet. And maybe I better do this in a way where I can see this without too much trouble. Hey, stop it. Oh, do I have to shrink it this way? Let me pause so I can get my act together here, and then you don't have to be bored watching me do this. Hold on. Hooray, I figured it out. Okay, so I'm going to take all these numbers and I'm going to just put them in. So we have a 10, stop it. We have a 10. We've got a 12. We got a 14. We got a 13. We got another 12. We got an 11. We got another 13. Got another 12. Got another 11. We got another 12, another 12, and another 13. Okay, so I want to make sure I've got all 12 numbers accounted for. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always a good idea to double check. 10, 12, 14, 13, 12, 11, 13, 12, 11 again, 12, 12, 13. All right. I've successfully transferred all of my data from the problem into the spreadsheet. And our task is to find the median and the median, and I think, no, the mean and the median, and also the range of the data. Okay, so first thing I'm going to do is this. I'm going to take all of these numbers and I'm going to highlight them. And then I'm going to come over to this symbol right there. It's called a sigma. And this allows me to use a bunch of different functions. And the average is what the spreadsheet calls the mean. So I'm going to click on average, and it's going to say, do you want to find the average of all these numbers? And I'm going to say, yes, let's find the average of all those numbers. And we get 12.08. Did I click that in the wrong way? Oh, no, there it is. There's the mean, 12.08, and I've rounded it. Instead of saying 12.08, 3 repeated, I rounded it to the nearest hundredth place. Did it tell us to round it anywhere, or did I just choose to do that? I think I just chose to do that. All right, so notice that it says equals average, and then parentheses, cell C1 to cell C13. So what I'm going to do now is I'm going to find the mean of all this data by saying equals median, oops, spell it correctly, median, parentheses, from cell C1 colon to cell C12, in parentheses. Now I'm going to click that, and that's my median. If you want to put them in order from least to greatest, you can highlight them and right click it, and it says sort range. When you sort from A to Z, that's like from smallest to biggest. You can sort them, and now you can easily find the median is the number in the middle. So this spreadsheet is wonderful for helping you find the mean. And when we do the Ms. Pac-Man project in probably April of this year, I'm going to show this to you again, and this is going to be your best friend, because finding the mean when you've got like 20 or 30 numbers can be a nightmare. But this will help you out tremendously. Okay, so just to show it again, what we do is put in a bunch of random numbers. Oh no, I didn't want to do that. Stop it. Why didn't it? Oh, I see what I got to do. Okay, so all right, let's find the mean. Highlight them all. Click on average, and there you go. 5.8 repeated is the mean of all of those numbers. What's the median? Equals median of cell E1 to E, what was the last one in there? Was that a 19 or was it 18? I think it was 18. 18, right? That's 18, yeah. So the median would have been 5.5. So when we go back to this, our median was 12, our mean was 12.08, and maybe I'll just write this in as with a 3 and a repeater, because that's the exact answer. And then the range. The range is the difference between the largest and the smallest numbers. So 14 minus 10 is 4. All right, and now for the last problem that we have here. Being able to change any decimal number to a fraction in simplest form or into a percent. Well, changing a decimal to a percent is easy. You just move that 2 places to the right. And in its percent form, 43% means 43 hundredths. And in fact, that is the name, 43 hundredths. So we write it as a fraction, and then look to see if we can simplify that fraction. If you want me to work out any of these others, let me know. Otherwise, I'm going to close out this video because it's almost going to 20 minutes longer than most of our homework videos. Any questions you have on any of these or want further clarification, just let me know. All right, take care. Bye.
Hey, feeling good, like I should.